In this video, I am going to explain the algorithm of splitting a child in a B tree. So when do we need to split a node in a B tree? First thing to know is the fixed integer t, which decides of the minimum degree and the maximum degree. For instance, here, minimum degree is t minus 1, which is 1. This means that we cannot have a node with less than 1 key. And the maximum degree is 2t minus 1. This means that we cannot have a node with more than 3 keys. Here we want to insert letter n. N is greater than L, so we go down right. N is less than SB, so we go down left. N will be inserted between M and P, so we'll have a tree like this one, M and P. So M and P contains 3 keys, which means that it is a full node. What does this mean? This means that we can no longer add in the nodes M and P. So now I want to insert letter O. So O is greater than L, so we go down right. O is less than SB, so we go down left. We have to insert O in this node, but this node is already full. What will we do here? We are going to split the node M and P into 2 nodes. How is this possible? We have the node M and P and we want to split it into 2 nodes. So algorithmically, we are going to create a new node Z in which we are going to insert t minus 1 elements, and we are going to reduce the size of y to t minus 1, which means we pass from a node containing 2t minus 1 elements to 2 nodes containing t minus 1 element. So the node Z that we are going to allocate will contain t minus 1 right element. T is 2, so t minus 1 is 1, which is p element. And then the size of y will be reduced also to t minus 1, which means that it will contain only 1 element, which means m. What happens to n? It will ascend to the parent node. N will ascend to the parent node. So to resume, y is the node to be split. Z is the node that will contain the right part of y after the median. The median here is n, and n will ascend to the parent node. So I am now going to explain the algorithm of split child. First, we have to remind that x is the parent of y is the node to be split, and I is the position of y in x, which means that y is the ith child of x. So as we said, we allocate the node Z in which we are going to put the right t minus 1 keys of y. If y is a leaf, then Z also is a leaf. If y is an internal node, then Z also is an internal node. Let's remind that leaf is a Boolean variable that is true if the node is a leaf. So after that, we are going to determine the number of keys that Z should contain. So after preparing the node Z, we are going to fill in it. For G in 1 to t minus 1, because we said that the node Z will contain t minus 1 element, and the new size of y will be also t minus 1. So what are we going to do? The new node will contain the elements after the median, which is here n. So n is at the position 2, which is t, the number t. Always the median is the position t. So kj of Z will receive kj plus t, which means after the median t, which means this element in this case, plus t of y. So in our case, the node to be split is a leaf. But what if this node is not a leaf? It would have 4 children. And if we are going to split the node into 2 nodes, these these four children also are going to be distributed between these two nodes. Now, if not leaf of y, if the node to be split is not a leaf, what are we going to do? For j in 1 to t, why t? Because when we have t minus 1 element, we have t children. This is a property. So Cj of z will receive the children after the median, so Cj plus t of y, which means that the node z will contain the children 3 and 4, the children after the median 2. So to resume, we filled in the node z and we filled in the children of y to z. Now since the node z is ready, we can reduce the size of y. And we have two nodes with t minus 1 keys each one. Now we finish it with the node itself and its children. The parent of y, the node to be split, used to have 3 children. Now it will have 4 children, so we have to update this up part. So what is the technique here? There will be another child 4. Since the key to be inserted is in this node, the first node, then 2 and 3 are going to be shifted. 4 will receive 3 and 3 will receive 2. And we will fill in the second position with the value of z, which is p, like you see here. Since we shift from the end, so our counter j will start from n of x plus 1 down to I plus 1. We insert in I, so the shifted element will start with I plus 1. Every time Cj plus 1, y plus 1, because the number of children has increased by 1, will receive the previous, which is Cj of x, and end 4. At the end, the element 2 in this case will receive the node z that we have prepared. So right now we shifted the children of right. Sorry, I repeat. So right now we shifted the right children to place the node z, but still we did not assign the median key, which is n, to the parent node. The median key is the key number t of the node y. It is less than SB because it is the left child of SB. So if it is going to be assigned, it will be before them. So same here, we are going to shift the element right to place n. So our counter will start with the number of keys of x down to I, which is the position of y in x, which is also the position that will take the median key. So for j in n of x down to I, do each time key j plus 1 will receive the previous element. And when we finish shifting, key I of x will receive the median key t of y. Always the key element, the median element is key t of y. Then of course the size of SV will become NSV3. N of x will increase plus plus. So we changed y, we changed x, and we changed z. So we are going to describe them all. Thank you for listening.